Good morning, chemistry students. This is going to be our review for a test we're going to take on Wednesday. It's going to be on chapters 9, 10, and 11. Unfortunately, I got this whole thing in pieces. So I'm going to do my very best to make this obvious what's going to be on this test. It's going to be vocabulary. But it's going to be could be a lot of vocabulary. So let's go ahead and start. Let's start with this. I hope this is the right thing. This is going to be chapter 9 stuff. And it's going to be hard to do. Let me see if I can highlight this. I'm going to try to make a list that I hope you make the same list. So here it is. The first definition of vocabulary of a compound. Now, compound is not new. This is an old this is chapter 9. Compound, not a new word, but anyway, there it is. And then chemical bond. What is a chemical bond? Now remember that you can pause me at any time if you need to highlight your work. And then table 9 is to show some physical part. Okay, here's what we're going to do on table 9. This is the important thing down there at the bottom. By learning how atoms combine, chemists can predict what substances will form under given circumstances. That's why we do all this. Okay, table 9.1. Know this table. In other words, know the characteristics of ionic compounds and those of molecular compounds, both. So there'll probably be some of these questions where you got to pick multiple choice, where you pick more than one word, that's one thing that's correct. Okay, so know these. Then bonds will tend to, okay, the octet rule down there at the bottom. The octet rule. Okay. Elements will tend to react chemically so as to achieve a noble gas electron configuration simply either by losing or by gaining electrons. So I'm going to use the last two bullets there. I'm going to combine those. The part starting with elements and the thing starting with by losing and gaining. Somehow, well, maybe not. Maybe I can get away with just the last one. The definition of the octet rule. We're going to go for the last one. Don't be surprised if I use some words from the middle one, but the last one is going to be the essence of the definition. And now, ionic bonds. What are ionic bonds? Notice the key thing, a transfer of one or more electrons from one to the other to satisfy the octet rule. Okay? Ionic bonds. And then the first two there. An anion, basically. Now we've had these before too, but why not? All right, this will be our last test, so why not? Okay, and then cation. Okay, so first two. Let's see. This is really important to know. Wait. Yeah, know this one. About in general. I'm gonna write in general. Elements, blah blah blah, ionic, crystalline, solids. Okay, so know this one. And then example 9.1, complete the handout for the bond, different types of ionic bonds. And that's it on ionic. This is the one I had in pieces. This is the part on ionic bonds. Then I have one that covers, let's see, that one. No, I have one that covers the other types of bonds, the covalent and then the metallic bonds. Okay, so let's look at this one. Let's see, slides show. All right. Let's see, bond, that part at the bottom about a bond is considered predominantly ionic if the electronegativity difference between the two bonded atoms is greater than 1.7. If it's less than 1.7, then it's predominantly covalent. So you got to know two things out of that. Two things on that one. What makes it ionic? What makes it covalent? Predominantly covalent. Okay, so we know. Electronegativity. I'm not going to worry about that. We got enough other stuff to worry about. Covalent is polar. Okay, know that the difference between polar and non-polar. Polar, covalent versus non-polar. Okay? Yeah. Let's see here. Okay. Yep. It's just repetitive there. A pure, know what a pure covalent bond is? Know what a dipole is. Dipole. Okay, we're not going to talk more about that. Is it polar? Okay, we did that. All right, that's it. I missed the C of. We didn't see any metal. Okay, for the metallic. Understand what makes it what it is. You know, why is it a metallic? Well, you know, we have the sea of electrons. Remember, I'm going to associate metallic bond with sea of electrons, so which explains its how well they conduct electricity and that kind of thing. So understand the what a metallic bond is. Metallic bond. I don't see it in any scraps of charts. I've got I really let this one fall apart. I have too many pieces on this one. Okay, so now let's go to no, not that one next. Next, let's go to selected metals and their compounds. Selected metals and their compounds. So this is chapter 10. And this one's going to be messy too because I had you do most of this. So I'm going to go through the book here in a second. But here, first, before we do that, from chapter 10, know these. Know hydrogenation. Know heavy water. What is heavy water? And I don't know if I covered that. I asked you guys to cover that, but know what that is. Know what an allotrope is. And then I'm not going to worry about those other ones down there. The normal oxide. Well, yeah, let's know. Let's know the normal oxide, the peroxide, and then I think there's one more. Well, I thought there was we have the high. Okay, we got that. Got this. Okay, here we go. the superoxide, the superoxide. Know what the ozone layer is. We should have written these terms down. Free radicals. What are free radicals? Know what nitrogen fixation is. Stay with me on this. I know this is going to be a long presentation, but we have to cover this. And then a halide. What is a halide? And that's it. Now, what I want to do now is go through the book. Because see, I didn't have charts on 10. I had you guys answer the questions and fill out your organizer. So here it is. This is what I've highlighted in my book. And most of them are important for one reason or another. Okay, so first, under hydrogen. This is 10.1. 10.1, hydrogen. We have steam reforming. Steam reforming. That's the way it's done industrially. And then in the laboratory, how it's formed using reacting with an acid such as dilute. Forget that. No. I'm going to put no. Forget that one. The primary use of hydrogen, or primary uses. Primary use. Actually, we have use. And then I also have another use. So you're going to have to know the use about liquid hydrogen. What's the liquid hydrogen good for? Liquid hydrogen. What's that good for? Okay. Then 10.2, oxygen. Oxygen. Know the properties of oxygen. Properties. Know how it's produced commercially. Produced commercially. Know what photosynthesis is. These are terms you know, but why not keep asking? You learned that one in school a long time ago. Then on page 153 we have uses for oxygen. Uses. We have one of the most important industrial chemicals and billions of okay. One major commercial use is the manufacture of steel. Okay, so know about. I'm going to put uses. I'm going to put steel. Is definitely one. And used in hospitals. In hospitals. Hospitals. How is it used in hospitals? There's different things, the ways it's used in hospitals. And that's it. I'll put no in this one. Uses of oxygen. Now, hydrogen peroxide. Still part of 2.2. Peroxide. You know, it's uses. Useful as mild antiseptics and more concentrated used to bleach textiles, can be used as a rocket fuel. Uses. No, all those uses. There's 3 or 4 there that can be used. I'll try to think of a way to do that so it's fair to you. Okay, now nitrogen. Probably the most important one we're covering here. Not really, but nitrogen. Still on nitrogen. We have properties. What are the properties of nitrogen? And then uses. The major use of nitrogen by far in the production of ammonia for fertilizers. Okay, and then nitrogen fixation. Nitrogen fixation. What is that? Know about nitrogen being an essential element in living organisms. Well, I mean, that whole thing is about nitrogen fixation. Know what that is. And then on the other side, both ammonia and ammonia salts must first be a similar process. Know about the nitrogen cycle. What is the nitrogen cycle? The nitrogen cycle. It's on page 157. Talks about it and has a picture. And then know about ammonia. Ammonia. A colorless gas within. What is ammonia? What is it? What? And then nitrogen oxides. Know what nitrogen oxides are. Let's see here. Know about nitrous. Let me just say this. Let's just know. I'm just going to specify nitrous oxide. Know about nitrous oxide. Okay. It's got lots of uses. It's important. So know just nitrous oxide. Okay, I'm trying to keep it simple here. We can skip the acid too. So nitrous oxide, what's it for? What can it be used for? Okay, so that's it on chapter 10. Whew, toughie. Now let's look at 11. Selected metals and non-metals. Let me see if I can highlight this one. Because this takes so much time to do it the way I'm doing it. Can't see any way to highlight this. What I'm going to do is I'm just going to go to different charts here. Okay, comparison of some physical properties of metals and. Okay, know about those. Chart table 11.1. This is chapter 11. Table 11.1. Know about that. The characteristics of metals and semi-metals. They may show up a few more other times, but that's really it. It's all on that chart. Okay, let's see. Know what metallurgy is? Metallurgy. Know what an ore is? Let's see. Unfortunately, though, we really have to go at more than. Let me go to a slideshow here. Well, we want to know what an ore is. You want to know that that first thing. Most metals in the form of minerals. Okay, so really this whole chart, pretty much. First process and product to take the ore to rock, crush it. Okay, the first, know the steps of processing metals, okay, because I don't want to go through that. So you know the first step is crushing it and creating this thing called gangue. Know what I forget how that's pronounced. Gangue. Know how to pronounce it. No, I'm just kidding. Know what it is. Know what it is. Well, let's see. We covered the first step is the crushing and the gangue. Then we have the flotation. What is the flotation step? I mean, that's used. Why do we need it? How's it done? Know about flotation step to separate copper, lead, and zinc from that other stuff when you start with the gangue. Okay, let's see what else we got now. The second step is to involves to reduce the metal in the compound to the free metal. This reduction know about that. The second step. It's, what's it for? What's the purpose of the second step? And and then we know we call it reduction, but involves a gain of electrons. Okay, we got to get free. That's about it. Know about the third step. Know about the electrolytic refining and the basic oxygen process. Comes out pretty clear when we start talking about iron. Finally, the final step. And know what casting is. And know what an alloy is. Okay. An alloy. And that's 11.1. 11.2, let's see. Was that, it's all about metal, huh? Yep. Then 11.2, alkali metals. Now we're talking about the first column in the periodic table. So 11.2, alkali metals. Know about, let's see, on this one, their properties down at the bottom. Properties. They're very soft, have a silvery appearance, very active, have excellent electrical and heat conductivity. And the thing, remember, to distinguish this from other metals, that thing that's there where it says very reactive. Remember the movie, the video, and that, I think it was, I don't know if it's sodium or potassium that went on, that lit on fire when it got in the water. So know about this. Know about that all alkali metals occur as cations with a positive one charge. Never found naturally. This test is going to be harder for me to write. As free elements. Okay. These metals are generally obtained by electrolysis. Know what electrolysis is. And know that this is the main method used. Let's see, the main method used to process them, to separate them from the other stuff they're hooked up to. Metals are generally obtained by electrolysis. Generally, okay. Process. Okay, know what electrolysis is. You probably know. Let's see. Okay, know how sodium is made. Sodium. Know that it's got to be NaCl and CaCl2. You know, that kind of thing. So know about these two things that are used to create or to make sodium, electrolyze, and then potassium. By comes from molten KCl. By electrolysis, by reaction with gaseous sodium. Okay, so how it's made, and then know how they make rubidium, and cesium, Uh, don't know. Don't worry about those. Don't worry about. Do not worry about rubidium or cesium. Let's see. Uses for sodium. Uses for lithium. Let's see. Do the right. Don't worry about rubidium and cesium. I'm probably going to regret that. Let's see. Yeah, that's it. I think I got it. Okay, these compounds, alkali compounds. Know about these. Know what they are. The ones that we've picked here. Know about. Know about sodium hydroxide. What is it used for? What is it? What's it used for? Let's see. Compounds of know about compounds of lithium and what they're used for. Used in dry cells, glass, ceramics, potatoes. Know about potassium compounds and that they're important to life, kind of thing. That whole little line there, and that you can use this potassium nitrate as a fertilizer, and we really already covered that a little bit, but you know. Okay, let's see. I think we already did that. Okay, we've already done that. And then the review. Whew. Didn't know we'd ever get through that. Okay, I already told you which ones we're going to worry about. Iron. Iron. I liked iron. I liked iron. So here, this is wearing me out. I know you guys must feel. Let's see. Know the properties of iron. And then know about rust. In other words, iron to oxide. Okay, so know about these two lines here on iron. Know about the blast furnace reduction. Know about blast furnace reduction. Okay, know what a blast furnace is? I'm going to put blast furnace. Know about this general thing about how a blast furnace works. You got to have a certain number of products in there. You know, the iron ore, the coke, I think the limestone, you have to have oxygen or air. Okay, it's going to work. And don't worry about that. See, there it is. What has to go in? What's the mixture? The mixture for iron. What goes into the top? We have those. And what are the products? The products. Pig iron. Slag. What is slag? Slag uses. Uses of slag. What is slag? Uses of slag. Okay, know about this slag. How do we get slag? Right here it tells you. And then it floats to the top. So you're producing pig iron and slag. And then if you put the pig iron in a mold, then it's cast iron. You casted it. Okay? Know what cast iron is? Cast iron. Know about it, what it is. There it is right there. Difficult to weld, not malleable or ductile. That's going to lead to the next metal, of course, steel. Then we got slag. What's it used for? Uses of slag. There's a whole bunch of them there. Okay, know what steel is? Steel. It's an alloy, of course. And it includes iron and small amounts of carbon. And then we're going to have different types of steels that will do different things. Know what carbon steels. Let's see. These are included carbon steel. Know about what mild steel is? Mild steel. Know what medium steel is? Medium steel. Know what high carbon steel is? High carbon. Sorry about that. Kind of losing it here. Getting tired. And then, carbon steel, about 90% of all steel produced. Know that. Carbon steel. 90%. About 90% of all carbon produced, of all steel produced. And then alloy steels. What is an alloy steel? It's not just steel. Steel's already an alloy, but this is another alloy. An alloy on an alloy. So we got, let's see, I'm not going to worry about those. Stainless steel. Know what stainless steel is. And uses. Stainless steel. What is it? It tells you the composition and what's it used for. How are we going to test this? See, I don't really want a whole bunch of stuff again. Well, know what vanadium steel is. And uses. Okay? Manganese steel. And purpose or use. Just say use. Purpose. Why do we add manganese to the steel? And it tells you why, right? It tells you because it's for very rugged surface, provides a hard, wear-resistant, self-renewing surface. Chromium steel. Let's see. The benefit of what is chromium steel? It's a lot to remember. It's a lot. But you had 2 days. You got tonight, today, and tomorrow to remember. Learn all this stuff for Wednesday. And the purpose. So why do we add steel? Increases its resistance to corrosion. I mean, why do we add chromium? It increases its resistance to corrosion. Nickel steel alloy. Just that first line. Well, the first line. What do we use it for? Nickel steel alloy. Just the first line. I'm going to put right here, first line. Tungsten. Just the first line. Tungsten steel. Primary alloy component in steel is used for tools and construction. Know that. There's a lot more cool stuff here, but I can't expect you to remember everything. It's too much. Okay, so molybdenum steel I'm going to say know the first two lines. First two lines. Because we want to know that it's high strength, used across a variety of industries, and steel alloys made with this molybdenum are not only stronger and harder, they're also highly resistant to heat and corrosion. Just that. Just that. And then two primary processes. Know the two. Whew. It's gonna be a toughie. Gonna be a toughie, guys. Basic oxygen process and the electro. You know, gotta know those two and how each is generally done. Okay, how each is generally done. So here it is, steel refining. Basically, blast furnace or they're super blast, sonic blasts of pure oxygen blown across the surface. So know the and know each. So you don't know that you don't need just to know that there's two main processes, but kind of how do they work? All right. And then let's see, the electric arc furnace. Know that description of that. Know both of them. The electric arc furnace. Let's see, typically this consists of cold steel. Know that these are the ones that are used in steel recycling. Okay, steel recycling. So just know the first part of that. I hope I remember that. You'll tell me if I don't. No. Now know, let's see, annealing. What's annealing? These are processes we're using now to make the steel better in some way. Used to remove and distortions. Know what it is and why do we do it. So this one here, for example, you would know that it's used to remove internal stresses and distortions in cooled metal. And then the last line, the annealing makes this metal softer and more workable. So know that. And then cold working. Cold working. Know what that is. And why we do it. To harden the steel. Quenching. Know what quenching. Another good definition. Think cold. You're dipping it in cold suddenly, right? Red hot metals cool quickly by dipping it in a bath of cold water. Or think about those old westerns with the guy that works with the metals out there banging away in the heat, and then he makes a horseshoe and then dumps it in the water, or a knife and then dumps it in the water. Tempering. What's tempering? To temper steel gently. Okay. What does tempering do? It makes the metal more resilient. Okay, so that's what you want to know. You want to know the first line and the last line. If the steel is too brittle after quenching, it may be made less brittle by tempering. This makes the metal more resilient. That's it. And then case hardening. Know what that is. The last thing. We're trying to make the outside harder or tougher. That's basically what it is. In cases where both toughness and hardness are desired. And it gives you a few examples. You can use this to harden the surface while leaving the interior resilient. That's all you got to know on that one. I think we might be almost done. That's it. Whew. And support. Oh, we still got to cover this one too. Whew. Goodness gracious. This is we really needed to have two tests on one. But okay, so here are the. You just saw this one, so you shouldn't have too much trouble with this one. Okay, let's see here. Silicon does not occur free, but as silicates. Okay, know that as silicates. And as silicates and the oxide, these two. Germanium. Know this one line about germanium. Not very common. Okay, know this one line about germanium. No, don't worry about that. Let's see, wait a minute. Okay, so know this process about making silicon or silica. How is silica processed? Heated with coke, and then we produce, by doing this, a 98% pure silicon, which can be used for quite a bit of thing. An alloying element. Know the uses. So know this whole line, really, basically. Know this whole line about silica becoming silicon. And then the uses, let's see, of silicon. Uses of silicon. I think we may have already said this, but in computers, except that it's got to be a whole lot more pure. So let's see if we talk about the purification process. And I'm not going to worry about that. Wait. Don't worry about it. Okay, know about the most common crystalline form of silica is sand or granulated quartz, though silica is also found in the form of flint. And then know about those gemstones. The gemstones come from them as well. And what kind of gemstones, of course. And then when silica is melted, okay, so know how we make glass. How do we make glass? And properties. So that's basically what this chart tells you. Properties and how we make it, sort of. We melt silica down. When it cools, it becomes this amorphous and non-crystalline state known as glass. It's transparent and solid, but it has some characteristics of a liquid. Okay, so does not flow. I'm gonna probably make that a two false questions. Does a glass flow? True or false? Okay, I'm gonna write that right here. True, false question on flow. Okay. Okay. Know about this type of glass. Glass made from pure silica. What's it called? And uses. And then window glass, also known as soda lime glass. Melting quartz sand with the sodium. How do we make it? How made? I know it sounds like a lot, but I'm not requiring you to know anything about the formulas. Okay? Okay, heat resistant glass. How do we do that? Heat resistant glass. How made? Whew! This is tiring me out. And then I'm going to say know about cut glass. Its contents. What's it called? It's called lead glass or flint glass. Okay, that kind of tells you what one of the things is probably in it. Boron. What it is and uses. Hey, you guys are gonna do fine on this. Don't get nervous about this test or anything. I'm done. Whew. That took a long time, I know. And just, spend a couple hours studying for this, and I think you'll be all right. You'll be okay. All right. So, whatever you do, remember, this is last week, and this next test is it in chemistry. So Wednesday, you'll be done after you take your test with chemistry.